So what we have here is a SepTec Turbojet 2000. The SepTec system is designed to treat up to 2,000 litres per day. It's a conventional aerated wastewater treatment system with 3 tanks. The tank here, we have the pump well with chlorination as the means of disinfection. This second tank here, we have the clarification chamber and the aeration chamber. In the aeration chamber, it's a little bit different to a conventional aerated wastewater treatment system because it uses a water pump for aeration. We'll go into that in more detail when we look at the aeration chamber. At the start of the system over here, we have our primary and secondary septic tank. As part of a 3-monthly service of this system, we're going to do a number of tests. Firstly, we're going to test for dissolved oxygen, pH and chlorine levels from the pump well. We're going to move along to the aeration chamber and the clarification chamber. And then what we're going to do is we're going to check for sludge levels and sludge build up in that clarification chamber. Moving along to the primary and secondary septic tank and also testing for sludge levels. We're then going to test the mechanical components of the system. We're going to test the high level alarm. We're going to test the float on the system as well to ensure that the alarm actually turns on. And then we're going to do a sludge return from the clarification chamber to ensure that that's pumping back into the primary chamber. The first test we're going to conduct is a residual chlorine test. You carefully lower the dip cup into the pump well, making sure that you're not scraping the sides and contaminating your sample. You bring your sample to the surface and using the test equipment that we have here, we're going to check for the chlorine levels. It's just a matter of breaking the test ampule off at the bottom. It'll then mix with the chemical in the ampule and change to a shade of pink. The optimum reading that we're looking for is a 0.5 to 2. So what we can do now is we put the test ampule on the comparator to get our reading. The optimum reading is 0.5 to 2 parts per million. You can see that the test ampule has gone a light shade of pink. The reading here starts at 1, so we're between 0.5 and 1 parts per million. The next test we're going to conduct is a dissolved oxygen test. It's the same process as the chlorine test. It's just a matter of cracking off that ampule in the sample, and you'll notice that the ampule will now change a different shade of blue. So the optimum reading is between 3 to 9 parts per million. You can see with this sample we're between 5 and 6 parts per million. Now what that indicates is an optimum environment for microbial growth. So if we have a reading between 3 to 9, that means that the environment within the system is going to promote that microbial growth to allow that waste to be digested. Always ensure that you dispose of all your sharps properly. And any contaminated equipment is properly cleaned and disposed of. The last test from the pump well is going to be a pH test. The optimum reading for pH is pH neutral. We have a range of 5.5 to 8.5. Now the reason why we take this test is to measure the pH, because if we're outside of the range of 5.5 to 8.5, it's going to affect our chlorine disinfection process. So we can see from conducting the pH test that we're around about pH neutral. What that indicates to us is that our chlorine is going to be most effective as a means of disinfection. If your pH is out, either too alkaline or too acidic, that's a good indicator that the householder is actually using products that may be putting that pH out. So it could be too much alkaline through overuse of dishwashers or too acidic. depending on what they're using within the household. The next test we're going to conduct is a clarity test. The most common way of testing for clarity is using a clarity tube. So we fill the clarity tube 300 millimeters with the end product from the pump well. To the 300 millimeter mark. You can see there's a hole in the clarity tube. That'll stop discharging at the 300 millimeter mark. I then sight down the clarity tube and I have a cross in the tube. If I can see the cross within the tube after sighting through the effluent, that indicates to me that we have at least 300 millimeters of clarity. While we're in the pump well, what we can test also for the operation of the pump, the operation of the high level alarm in the pump well, and also replenish the chlorine tablets. We're now going to test for the operation of the pump. Now when we do this with a system with drip irrigation, it's really important that we go to the flush point and flush the system out to ensure the pump is actually discharging adequately to that land application area. We can see that the pump is working adequately. We can now move to the high water level, a high water alarm in the pump well. The high water alarm will give us an indication if the water level inside the pump well is to increase because of pump failure. In this case, a light will come on the system. Now going to lift the high level alarm. Although it's difficult to see in the sunlight, we'll see that the light is actually coming on the control panel. As a means of disinfection, as we know that this system uses chlorine. This is our chlorine dispenser here. As effluent enters the pump well, it trickles over the chlorine tablet, comes in contact with the chlorine, and that's how we get our disinfection. It's important that at this point we actually replenish the chlorine tablets to ensure that we have 3 months supply of chlorine in the dispenser. So where this system differs from a conventional aerated wastewater treatment system, it doesn't have a blower. So located in the aeration chamber here is a submersible pump. It's circulating water through a manifold which is below the media in the aeration chamber. As it's circulating the water through that manifold, it's drawing air in through the tube located here, thus allowing aeration in that aeration chamber. In addition, it also has a sludge return. So by opening these valves here, it bypasses air through this manifold and takes sludge from the clarification chamber and pushes it back into the primary septic tank. As you can see, this sludge return pipe is blocked. The sludge return pipe is discharging sludge from the clarification chamber and should be returning the sludge build-up in the bottom of the chamber to this primary septic tank. But because it's blocked, it's not allowing that to occur. So even with the 2 sludge return valves open, we're not able to actually remove the sludge from the clarification chamber and taking it back into the primary septic. We're now going to conduct the first of our sludge tests. We're going to take a sludge reading from the clarification chamber. Now, considering that we don't have a sludge return pumping back into the primary septic tank, it's fair to assume that there'll be a fair degree of sludge build-up in that clarification chamber.
Okay, when you place the sludge judge into the chamber and it reaches the bottom, close the valve and carefully lift the sludge judge up. It will capture the contents of the chamber. And we can see, if you give it a few moments to settle, you can see the accumulated sludge in the clarification chamber has reached between 300 and 400 millimetres. And this has occurred because the return is not working. Having removed the sediment from the clarification chamber, you can return that to the primary chamber. You place the sludge judge into the primary chamber and release the valve.
Because of the build-up, the accumulation of sludge in the clarification chamber, we've also taken a sludge reading in the aeration chamber. By looking at the reading in the sludge judge here, we have a slight accumulation of sludge down the bottom of the sludge judge. Now this isn't too much of a concern, but we really do need to ensure that we get that sludge return working from the clarification chamber back into the primary chamber. We've now completed our tests in the pump well, the clarification chamber and the aeration chamber. We're now moving to the septic tank. We're now going to take a sludge reading in the secondary side of the septic tank.
It's pretty good.
And as you can see, the sludge build-up in the sludge judge is around about the 150 to 200 millimetre mark. It's important that you record those readings in your service report. We're now going to take a sludge reading in the primary septic tank. Now it's expected to find a greater accumulation of sludge in the primary septic tank compared to the secondary septic. Once that sludge settles, we'd expect to see between 200 and 250 millimetres of sludge. When taking your sludge reading, when 2/3 of the sludge judge comprises of sludge and scum, it's time to pump out that septic tank. Because we still have access to the pump well, now's a good opportunity to run the pump and check the land application area. The land application area is towards the rear of the property. Polyline runs round here to the right and to that land application area. So what we have here is the land application area in the rear of the property. The land application area comprises of pressure compensated drippers in this 300 square metre area here. Located here are our filter bank with the filter and also the root inhibitor. Coming over to the high side of the land application area here is our air release valve. From the air release valve, I walk down and you can see the laterals where the drippers are located in this nice sunny land application area. Laterals are around about 1 metre apart. And coming down to the low side, the far end of the land application area, what we have here is the flush point. And the flush point comprises of a turf valve where we can actually flush the lines, run the pump and remove any residue that's actually built up in the drippers. Notice also that there's signage in the land application area in 2 locations, up in the high point here and also down in the low point here. An important component of the land application area when you have pressure compensated drippers is the filter bank. The filter bank in this case comprises of below ground filters, which has a cartridge filter in place that will prevent any residual passing through the filter and blocking up your drippers. The second cartridge here on the right hand side is our root inhibitor. The root inhibitor is a cartridge which is replaceable, and what it basically does is puts a chemical in the effluent which just prevents any roots, any of those small roots from growing inside the pressure compensated dripper and blocking up your drippers. In the highest part of the land application area is the air release valve. When the pump is in the off position, the air release valve is open. When the pump turns on, the air release valve will shut and allow the effluent to drip through the drippers. The whole purpose of the air release valve is to relieve that residual pressure in the laterals when the pump is in the off position. On the far side of the land application area, we have the flush point. Now the flush point comprises of a turf valve. I'm now going to use the turf valve just to flush any of that residual build-up in the laterals. At the completion of the job, it's really important that we clean and sanitise all the equipment. As part of your pack-up clean-up, it's always important to make sure that your hands are properly sanitised.
Put it in the outtakes.
Now let's do that again. I wasn't happy with that, Terry. When the pump is then activated, hang on, take it back, wrong way around. Damn it! Put in the start again.
Hi, we're here to service your SepTec Turbojet 2000.
Okay, perfect.